Right now, you are feeling something. A pressure in your seat, a weight in your feet, a kind of heaviness that you felt every single second of your life. You've always called it gravity. But here's the thing, what you're feeling isn't gravity at all. In fact, it is physically impossible to feel gravity. And once you understand why, you will never look at the ground beneath you the same way again. Let's start with something simple. Something you've probably never questioned. When you stand on a scale, what is the scale actually measuring? Most people would say, your weight. And weight, they'd say, is gravity pulling you down. That sounds completely reasonable. It also happens to be not slightly wrong, but fundamentally, structurally wrong in a way that changes everything. Here's the first crack in the story. Imagine you're in an elevator. The doors close. The elevator starts moving down. Fast. For just a moment you feel lighter. Your stomach lifts. If the elevator were in freefall, if the cables snapped and nothing slowed it down, you would feel completely weightless. Zero. Nothing. The same sensation astronauts feel in orbit, but gravity hasn't disappeared. Earth is still pulling you down just as hard. So why do you feel nothing? Pause and predict what happens next. If gravity is a force pulling you down, and you're in free fall directly toward Earth, why would you feel lighter? The force hasn't changed. You haven't moved away from the planet. So what exactly went away? The answer will take a few minutes to fully land, so hold that question. Here's a misconception that most people carry without even realizing it. We think of gravity the way we think of someone pushing on our back, a force we can feel, a pressure we can sense. But think about every force you've ever felt. When someone pushes your shoulder, you feel it because your skin compresses, your muscles resist, nerve endings fire signals to your brain. Every force you have ever consciously felt in your life involved something physically contacting part of your body and deforming it. Gravity, as we've been taught it, acts on every single atom of your body equally, simultaneously, in the same direction, at the same rate. There's no deformation. There's no deformation. There's no signal to send. There's nothing for your nervous system to detect. What your body can detect, what the scale is actually measuring, is the ground pushing up. That's it. The entire sensation of weight, the heaviness in your legs right now, the pressure in your back as you sit. None of it is gravity pulling you down. All of it is the surface beneath you pushing up. The floor is constantly accelerating you upward, preventing you from following the natural path your body would take through space-time. You feel the resistance. You feel the interruption. You feel the ground refusing to let you fall. This is where the story gets genuinely strange. In freefall, in that elevator with the cable cut, or in orbit around Earth, nothing is pushing on you, no surface, no resistance. Your body follows its natural path through space-time, and every atom of you moves together equally with perfect uniformity. And because there's no contact, no compression, no deformation, you feel nothing. Not because gravity weakened, but because for the first time nothing is fighting it. Notice how your intuition expects freefall to feel violent and chaotic. It doesn't. It feels like floating. It feels like rest. Now here's where the rabbit hole deepens. Einstein looked at this and realized something that should not have been possible to realize just by thinking carefully. He realized that free fall and hovering in empty space, completely free from any gravity, any planet, anything, are physically identical experiences. You cannot from the inside tell the difference between floating in the void between galaxies and falling in a perfectly smooth gravitational field. They feel exactly the same, nothing. And if two situations are physically indistinguishable from the inside, if no experiment you could perform while inside them would tell you which one you're in, then on some deep level, they are the same situation. This is a simplified explanation to make the core idea intuitive. But here is what that equivalence actually implies. If freefall feels like no gravity and floating in empty space feels like no gravity, then what is the person standing on the ground actually experiencing? They're the one with forces acting on them. They're the one being accelerated. They're the one in the non-inertial state. The person standing still on Earth is, in the language of physics, less at rest than the person plummeting toward the ground. Let that sit for a moment. You've spent your entire life thinking of the falling person as the one being acted on, the unusual case, the dramatic one. But from the perspective of physics, from the geometry of space-time, you, sitting or standing right now, are the one in the strange situation. The ground is pushing you away from the path you would naturally take. Gravity isn't a hand pulling you down. It's the absence of anything pushing you away from a curve. This is the midpoint, and it's also where the real question finally appears. If gravity isn't a force, if it's just the shape of space-time, and objects follow that shape freely, then why does anything fall at all? What is actually happening when an apple leaves a branch? Here's the thought experiment. Imagine space-time as a stretched fabric, not because this image is perfect, but because it captures something true. A massive object like Earth sits in that fabric and creates a curvature around itself. Now imagine an object, the apple, with no forces acting on it, simply moving forward through time. It is always moving through time. Every object is. And as it moves through time in curved space-time, the most natural straight-line path it can take, what physicists call a geodesic, happens to curve toward the Earth. The apple isn't being pulled. It's moving in a straight line through bent space. Falling is the straight line. It's us, standing on the ground, being pushed off the straight line, who are doing the unusual thing. Pause and predict what happens next. If this is true, if gravity is geometry and not a force, what does that mean for something that has no mass? Something like light? Light has no mass. A force acting on mass would do nothing to light. So if gravity was simply a force like magnetism or friction, light should pass through a gravitational field completely unaffected. But it doesn't. Light bends around massive objects. We've photographed it. We've used it to see galaxies that should be hidden behind other galaxies, using the mass in between as a lens. Light bends because space-time itself is curved, and light follows the shortest possible path through curved space-time, just like everything else. This is one of the most tested, most verified predictions in all of science, and it only makes sense if gravity is geometry, not force. Here's the real-world anchor. GPS satellites have to account for the fact that time runs slightly faster in orbit than on Earth's surface, because the curvature of space-time near Earth's surface runs slower in a very precise, measurable way. If engineers ignored this effect, GPS coordinates would drift by kilometers within a single day. The correction isn't theoretical. It's built into the system. It's running right now, invisibly, every time your phone knows where you are. The universe is using curved geometry to navigate. We just built a machine that had to learn the same lesson. Now, come back to where we started. That sensation you felt every day of your life, the heaviness, the weight, the sense of being pressed into the world. It is not gravity. It is the world pressing back. Every surface you've ever touched has been pushing you away from the freefall path you would naturally take. The weight in your feet is the Earth's crust saying, not this way. Your body interprets that resistance as weight, as down, as gravity. But those are names for the sensation, not the cause. The cause is that you're being held away from the curve. Most people assume astronauts in orbit have escaped gravity. That's another misconception that quietly shapes the whole picture. Astronauts in the International Space Station are still well within Earth's gravitational field. Earth's gravity at that altitude is roughly 90% as strong as at the surface. They're not beyond gravity. They're in freefall, constantly falling toward Earth, but moving sideways fast enough that they keep missing it. The orbit is a controlled fall. The weightlessness is the absence of the ground, not the absence of gravity. And here's what that means for you. Every moment you feel grounded, every moment of heaviness and solidity and physical presence is a moment of resistance, a moment of being held back from the natural geometry of the universe. The universe wants you to fall, not destructively, not violently, just freely along the curve. The ground won't allow it. And that friction between what the universe permits and what the Earth prevents is exactly what you've always called feeling real. The ground isn't holding you up. It's holding you back. And the moment nothing holds you back, the moment you fall freely through space-time with every atom moving in perfect unison, you feel nothing at all. That is what it feels like to be at peace with the geometry of the universe. You have never felt gravity. You have only ever felt everything that was fighting it.